The examples for today focus on two topics. 1. Units analysis is a method of systematically converting from one unit of measure to another. For example, you might need to convert paces to kilometers or miles. Or you might need to convert 30 feet per second into an equivalent speed in miles per hour. 2. You will see some examples of the close relationships that exist between rates and arithmetic averages. Every arithmetic average is a special kind of rate, and every rate is a special kind of average. Let's begin by looking again at the problem of a toy car gradually increasing in speed as it rolls down a hill. If we measured how low it took for the car to travel a short interval at the end of the hill, then we could get a reasonable estimate of how fast it was going. For example, if the car traveled 30 feet in 1 second, then we could use units analysis to convert from feet per second to miles per hour. Or, if we measured in meters per second, then we could use the same techniques to convert to kilometers per hour. Here is how the method works. First, notice that 5,280 feet equals 1 mile. So, if you multiply some quantity by the quotient of 1 mile and 5,280 feet, then this is equivalent to multiplying by 1. So, this does not change the value of the original quantity. Similarly, notice that 60 seconds equals 1 minute. So, if you multiply some quantity by the quotient of 1 minute and 60 seconds, then this is equivalent to multiplying by 1. So again, this does not change the value of the original quantity. And similarly, you can multiply by the quotient of 60 minutes and 1 hour, and the value of the original quantity will not change. Therefore, by using strings of multiples of 1, you have a method of converting from one type of unit to another as shown here. Now, as you can see, units analysis solves the unit conversion problem, but it does not solve a deeper problem. That is, the speed of the toy car is continually changing as it rolls down the hill. So, for any interval of distance that we measure, the best that we can do is to calculate an average speed over the interval. In fact, because speed is defined as the distance traveled during an interval of time, mathematicians had to be very clever to figure out a way to measure speed at a point when there is no interval. Calculus was the answer. And the secret to success was to find ways to find the limit, or trend, in speeds that are calculated over increasingly smaller intervals. For our purposes in this course, we do not need to get involved in details about computational methods for finding speeds for instance of time. But, we should notice the ways that rates involve averages. And similarly, averages are special kinds of rates. For example, imagine a group of all-star baby basketball players, and consider what happens when we calculate the average height of the team. First, you calculate the sum of the players' heights. Then, you divide by the number of players. But, remember units analysis. The formula would look something like this. 34 inches, plus 35 inches, plus 36 inches, plus 37 inches, plus 38 inches, all divided by 5 babies. If we don't calculate with naked numbers with no unit labels, then the result of this calculation is 36 inches per baby. In other words, the answer is a rate. Later in this course, you'll often be dealing with both rates and averages in a single problem-solving situation. And different analysis techniques often result, depending on whether you average first and then calculate rates, or whether you calculate rates first and then average.